This video is about calculating with parameters concerning the number of solutions or x-intercepts. Consider the following question. Given the equation x squared minus 3x plus 2p is equal to 0, for which p does this equation have no solutions? Well, a quadratic equation such as this has two solutions for a discriminant larger than 0. For a discriminant equal to 0, it has one solution. And for a discriminant lower than 0, it has no solutions. So our first step will be to calculate d in terms of p. In this equation, a is 1, b is negative 3, and c is 2p. So our discriminant is equal to b squared, so 9, minus 4 times 1 times 2p, or equal to 9 minus 8p. In order to have no solutions, we know that this discriminant 9 minus 8p should be lower than 0, so we can now generate and solve an inequality. In this case, the inequality is 9 minus 8p is the discriminant should be lower than 0. So that gives us that negative 8p is lower than negative 9, or p is larger than 9 divided by 8, or 1/8. Note that because in this last step we had to divide by a negative number, negative 8, we had to flip the sign. So this answers the question that for p is larger than 1/8, the equation has no solution. Let's look at another example. For which p does the function gx is negative 2x squared minus 4px plus 3 have two x-intercepts? Well, asking about the x-intercepts of a function is basically the same as asking when does minus 2x squared minus 4px plus 3 is equal to 0 have two solutions, because x-intercepts is the solution to gx is 0. So the same thing as above is true. For d is larger than 0, there are two x-intercepts. For d is equal to 0, there is one x-intercept. For d is smaller than 0, there are no x-intercepts. This tells us that in this situation, just like before, we have to determine the function of the discriminant as a function of p before we can solve this. The discriminants can be calculated by b squared. b is negative 4p, so b squared is 16p squared minus 4 times a times c, or 16p squared plus 24. Now that we know the discriminant as a function of p, we can generate the inequality where d is larger than 0 to solve this question. So we have to solve when is 16p squared plus 24 larger than 0. Now this is a little more of a problem than our previous example, because in our previous example the inequality we generated was linear. This inequality is quadratic because the p is squared. When we are solving a quadratic inequality, we have to first change the inequality to an equation. So 16p squared plus 24 is equal to 0. Then we can solve this by saying 16p squared is negative 24. Well, we can divide both sides by 16, but both 16 and p squared is positive, so this side is positive and this side is negative, so there are no solutions. Well, that doesn't mean that we cannot solve the exercise. Let's look at this equation and note that 16p squared plus 24 is quadratic, and if we were to draw the graph of this discriminant, it would be a cup parabola because 16 is positive. So it's a cup parabola. Also, it has no solutions with d is 0, so there is a d is 0 line somewhere over here, and there's a gap because there's no solutions. So that means that for any p, d is larger than 0, because the graph of d is above d is 0. So d is larger than 0 for all p. Let's look back. What did we need? We needed d to be larger than 0 for there to be two x-intercepts. So we can conclude as a last step, so two x-intercepts for all p. So in situations like this, for example, when you have an equation and you want to know how many solutions it has, and the equation is quadratic, or you have a quadratic function and you want to know how much x-intercepts it has, what you do is calculate d in both cases, and when you have d, you can generate an inequality and therefore you have to know that if there are two solutions, d is larger than 0, one solution, d is equal to 0, no solutions, d is smaller than 0, and the same for the number of x-intercepts. So you calculate d, you determine whether it should be smaller, larger, or equal to 0, and you solve the inequality or equation you get.